This is Algebra 2, Lesson 8.4, introducing logarithmic functions. We're going to evaluate logarithmic functions, and then we're going to graph them. In fact, we probably won't graph very many of them. Beginning on page 486 in the textbook. Two definitions to begin: a common logarithm and a natural log. Common logarithm is one that has a base of 10. Um, this is the same thing when you just see the word log and there's no base written beside it. If you just see log and there's nothing written here, it's assumed to have base 10 there. Um, Otherwise, you'll see log with a different base number, like log base 3. There'll be a subscript in there. So it has a base of 10 if there's no number. A natural log has a base of E. That letter is E. E. And you won't, this one, anytime you see natural logs, they won't be written with the word log at all. It'll be written with LN. Notice you ought to have calculators sitting in front of you. You'll see another button that says LN. That's for log natural or natural log. But again, LN is natural log, so they have a base of E. So anytime you see LN, there won't be a number there either, because its base will be E. If you see LN with a number, then you'll do it with that base instead of the E that the 10 is in place when it says log. The definition of a logarithm with a base b says let b and y be positive. So we're not talking about negative numbers here. Remember, negative numbers, all they do in regarding exponents is make the elevator rule happen. Where b's not 1. And the reason b is not 1 is because it's not going to change what the number is. The logarithm of y with base b is denoted by log base b of y and is defined as follows. Log base b of y. Notice how I'm reading this little phrase right here, everybody. You read this as log base b of y. If you don't read it that way, you're going to write it the wrong way. And if you write it the wrong way, you're going to solve it incorrectly. So make sure you read it starting right now as you're reading it to yourself. As I'm reading it out loud, read it the way I'm reading it. Log base b of y is equal to x if and only if when you raise b to the x power, it's equal to y. So the expression log base b of y is read again as log base b of y. Right here, the logarithmic form is log base 3 of 81 equals 4. So when you write logarithmic form in an exponential form, or when you write it exponentially, you're writing it as log base 3. So notice this is the base right here, 3. This, but again, log base 3. So that anytime you see that the subscript down there, 3, remember, if you don't see a number like that 3 down there, you assume that 10 is there. Just like when you see 4 to the something power and there's not anything there, you know that something is 1. Remember, I always represent that with 1. If there's no base number, it's 10. But what this is saying is 3 to the 4th power is equal to 81. That's how you read that exponentially from logarithmic form. The second form is something becoming the number 1. So this one, you read it as log base 4 of 1. Practice it in your head right now. Log base 4 of 1 is 0. You'd read it just like that. So that's 4 to the 0 power is equal to 1. Remember, anytime to get 1, you raise something to the 0 power. Log base 9 of 9 is 1. Anytime you have the same number, right here, both of these are right next to each other. Log base 9 of 9 is equal to 1. Those cancel each other out. And I'll show you what that means when we solve these equations in just a minute. But 9 to the 1st power is equal to 9. Log base 10 of 0.01 equals -2. Remember what I told you earlier about, instead of writing this as a decimal, write it as a fraction, and it's a lot easier to deal with. 0.01, that 1 is in the hundredths place. So it becomes 1 over 100. So what it's saying is log base 10 of 1 over 100. That is the same thing. This is exactly the same thing as this. 0.001 is equal to negative 2. And again, just like the bell word, when you flip 10 over 1, it becomes 1 over 10. That's where the negative comes from. Remember, the negative makes it ride the elevator. And to make 10 into 100, you multiply it by 10 one more time. So that's why it becomes 10 to the second power. Or negative 2 makes it flip. Or negative makes it flip. 2 makes it become the number 100. So what this is saying is log base 1/4 of 4 is equal to negative 1. Again, we're changing, all we're doing is converting this from log form to exponent form. 1/4 to the negative 1 power is 4. And again, all a negative exponent tells you to do is ride the elevator. 1/4 rides the elevator, 4 goes up. It doesn't turn the number negative. It doesn't turn it positive. It just makes it go, in this case, from 1/4, 4 goes up and becomes positive 4. So 1/4 to the negative 1 is equal to 4. Okay, on the back, everybody, or in the margin, wherever you have some space, let's do these. Write this log form, log base 3 of 9 equals 2. Write it in exponent form. Look at example number 1 to where you can see exactly how to do it. Take about 30 seconds. Okay, not quite 30 seconds because we don't need it. But again, as you read this, you read it as log base 3. So that's going to be your base, 3. Log base 3 of 9 equals 2. And you could easily mentally check that. You can easily see that 3 squared is equal to 9. All we're doing is we're going backwards with stuff that you already know how to do. We're trying to logically learn it in reverse. That's what logarithms are for, in the way we're going to use them. 3 to the second power. So 3 raised to the power after the equal sign is equal to what's after the base. Okay, try this one too. Okay, again, you're making something into the number 1. So it's saying log base 8, so 8, to the what power is equal to 1. And again, we know in order to make something turn into the number 1, you raise it to the 0 power. We're not doing any calculating or figuring here. All we're doing is rewriting from one form to the other. So 8 to the 0 is equal to 1. And let's try this last one. This one looks hard, but it's not. Log to the 5th power. I'm sorry, see how I just read it. Make sure you read it correctly. Log base 5 of 1 over 25 is equal to negative 2. Follow the same format as A and B. Again, you're not doing any figuring or calculating here. You're just reordering it. Log base 5 of 1 over 25 is negative 2. That's how it'd be written exponentially for A, B, and C. Anybody have questions on those? Okay, then we have 2 checkpoint problems. Rewrite both of these in exponential form. The first one's easy because it's simply log base 3 of 3 is 1. So 3 of 3 is 1. So 3 to the first power equals 3. Simple. Just rewrite. The second one is easy as well. Once you get past the fraction, once you get past the decimal, once you get past that phobia that we all have of fractions, 0.125, just like I told you earlier, tenths place, hundredths place, thousandths place. If you convert that, you got 125 over 1,000 or 125 thousandths. So then you just need the number that simplifies both of those to where you can get a good fraction. Okay. Um, but for the simplicity, I should say, of this exercise, we probably don't even need to do that because, again, you're not doing any calculating yet. You're just simply saying log base 2 of 0.125 is -3. That's just rewriting it in exponential form. What I was doing a second ago, moving this over and changing it to 125 over 1,000, is what you're going to do when you actually start calculating it. But this is all they want us to do here for this. And these are special logarithmic values. It says let b be a positive real number, and then b not be the number 1, because it wouldn't change what it is. Log base b of 1 is equal to 0. Okay, so we had one like this a second ago when we raised 8 to the 0 power to get 1. Anytime you want the number 1, anytime the number 1 pops up right here, it's going to be to the 0 power. When log, and I mentioned this one just real quickly, anytime you have the same base as what you're trying to figure, they're going to cancel each other out. So this number happens to be 1 after it. Whatever that number happens to be is what it's going to be. And again, when we get to those problems, I'll show you exactly how they cancel each other out. That's going to be your goal, is to cancel them out. So example number 2 is evaluating these expressions. It's saying log base 2 of 64. And then it does is what? Like it doesn't have the rest of the equation. So it says to help you find the value of log base b of y, ask yourself what power of b gives you y. So the first one, 2 to what power gives 64. So if you have those charts I made for y'all, you can just look on the left-hand side, find the number 2, and then run till you get over to the number 64, and then look up and see what power that is. Now, we know that 2 to the 6th power is 64. Therefore, log base 2 of 64 would be equal to 6. The second one says log base 1/2 of 0.25 equals what? Again, you're asking yourself those questions. 1/2 to what power is 0.25? You have two different versions of a number. You have a fraction 1/2, and you have 0.25. That's a decimal. You should know that 0.25 is 1/4, 25%, or 25 of 100. And when you're talking about dollars, you know that that's a quarter or a fourth. But if you don't, like I showed you a minute ago, that 5, the last digit, or the last, it's in the hundredths place. So that's 25 hundredths. Now you can see that it's 25%. That's the same thing as 0.25. And the number 25 goes into these. It goes into this one once, into this one 4 times. So what it's saying is 1/2 to what power gives 0.25. Okay, so you're not going to flip it, because 1/2 becoming 1/4 stays just like it is. You're just raising it to the second power, because 1/2 to the second power, because when you raise 1 to the second power, it doesn't change 1. But when you raise 2 to the second power, the bottom one, it gives you the number 4. And 4 is 1/4 in this case, which is 0.25. And we'll pick up with the rest of them tomorrow.